Hello and welcome to our lesson on reflections in geometry. Today, we are going to explore the intriguing concept of reflections and how they can be performed and described on the coordinate plane. In this lesson, we'll build on what we already know about shape transformations by diving into reflections. First, we'll understand what a reflection is in the context of geometry. Then, we'll learn how to perform reflections on the coordinate plane, using a ruler to visually represent the transformation. Finally, we will look at specific examples to apply this new knowledge and reinforce our understanding. So far, we've talked about rotations, which involve turning a figure around a point. Rotations are a type of transformation that alters the position of a shape while maintaining its size and shape. This groundwork gives us insight into how shapes can move and change position on a plane. With this understanding, we're ready to delve into reflections. Reflections are another important type of transformation. They are used extensively in geometry to study the properties of shapes, especially in symmetry problems. Imagine you have a geometric figure, like a triangle, and you need to reflect it across a given line, such as the x-axis or y-axis. Knowing how to perform this reflection allows us to precisely describe where each vertex of the triangle moves to on the coordinate plane, enabling us to tackle problems involving symmetry and congruency with ease. Let's get started! Let's have a look at some key concepts we will be using. A reflection is a transformation that creates a mirror image of a figure across a line called the line of reflection. We have the mirror line, the line over which the figure is reflected. Finally, we have the mirror image, the reflected figure, which is the same distance from the line of reflection as the original figure, but on the opposite side. Now let's see how we actually perform a reflection. To perform reflections, we use a step-by-step process with a ruler to ensure accuracy. Step 1. Identify the line of reflection. Determine whether the reflection is over the x-axis, y-axis, y equals x or y equals minus x. In this case, we are using the x-axis. Step 2. Use a ruler to draw perpendicular lines. From each point on the original figure, draw a line perpendicular to the line of reflection using a ruler. Measure the distance from the original point to the line of reflection. Step 3. Mark the reflected points. Measure the same distance on the opposite side of the line of reflection and mark the new points. This is now your reflected image. Let's now work through with an example. Imagine you have been given this question: reflect point A over the y-axis. First, we will start by drawing a perpendicular line from point A to the y-axis, then measure the distance. Next, we will mark the reflected point on the opposite side of the y-axis. Finally, we can plot the new point on the coordinate plane. Let's look at a second example to solidify our knowledge. Question 2. Reflect point B over the x-axis. Start by drawing a perpendicular line from point B to the x-axis, then measure the distance. Next, mark the reflected point on the opposite side of the x-axis. Finally, plot the new point on the coordinate plane. When given a figure and its reflected image, you can also determine the line of reflection by comparing the coordinates of corresponding points. The original triangle ABC has points A, 1, 2, B, 3, 4, and C, 5, 2. The reflected triangle has points A', 1, minus 2, B', 3, minus 4, and C', 5, minus 2. By comparing coordinates, we can find the line of reflection. Point A, which is 1, 2, becomes I', 1, minus 2, indicating a reflection over the x-axis. Looking at some real-world applications, reflections are commonly used in various fields such as art and design to create symmetrical patterns and designs. For example, designing a logo that has a symmetrical shape or mosaic patterns. It is also used in engineering to analyze symmetrical components and structures. For example, designing a bridge with symmetrical support beams. Finally, in physics, it is used to study light reflections and mirror images. For example, understanding how light reflects off a surface to form images. In today's lesson, we explored the concept of reflections in geometry, focusing on how to perform and describe reflections on the coordinate plane using a ruler. We began by defining what a reflection is. It is a transformation producing a mirror image of a shape over a specific line, known as the line of reflection or mirror line. We then practiced reflecting shapes over common lines, such as the x-axis and y-axis, by drawing perpendicular lines and measuring distances. By following these steps, we ensured accuracy in our reflections. Finally, we applied these concepts to solve various geometric problems, reinforcing our understanding of reflections and their properties. By mastering reflections, we can more easily manipulate and analyze shapes within the coordinate plane, which is an important skill in geometry.